Okay, so we're going to take a look at using the phrase is a function of. Decide whether A is a function of B. Okay, I'm going to distinguish between these by coloring them. B is a function of A, or neither. It says the UPC, Universal Product Code, and this is this right over here, right? You've seen these at the grocery store. At actually any place where you buy an item that's packaged for sale. It says the UPC on an item in the grocery store consists of 12 numerical digits that are uniquely assigned to that item. The UPC code includes the name of the item and the price of the item, in addition to other data about the unique item. So each item has its own 12-digit code. It says let A be the UPC code and B be the price of the item. Now, A is going to be the UPC code. So let's set up the first situation where we're asking ourselves, is A a function of B? So here we go. Let's take a look. A being a function of B means A is a result of B. And so I'm going to put the A over there and the B right here. Okay, so is a function of means result. Unique result, right? So there we go. So A is the code and B is the price. So what I'm looking to do is to see if I can create basically this open beak. And if I can create an open beak, then we do not have a function. Here's what I mean. Let's just say something is 99 cents at the grocery store. 99 cents. All right, is it possible that the code, let's just say the code is, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11, 12. There's the code, 12-digit item. Okay, code. So is it possible that something else in the store actually has a different code that's 99, something else that's 99 cents that has a different code? Well, certainly. There's a lot of things in the grocery store that are the same price. So I could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 2, 5. There we go. Because I'm able to make an open beak, okay, when I say open beak, like a bird, a beak on the bird, because I'm able to do that, that means that I have one input, one x coordinate, producing two different y coordinates. When I take a look at graphing that, then I would have two dots lined up vertically, right? Which means it does not pass the vertical line test, which means it's not a function. So this is not, okay, a function. So this is A is not a function of B, because I was able to make an open beak. Now that's kind of sounds silly, but it works. If you can, going by the guidelines of the stated problem, if you can create an open beak, then it fails to be a function, is not a function of B. A is not a function of B. Let's take a look at the next scenario where they're saying, hey, well, what about B being a function of A? All right, well, let's just try to create an open beak using the scenario we have. So we're going to go ahead with 1, 2, 3, 4, 5, blah, blah, blah. That's first one, and then 1, 2, 3. So there's my UPC code. And let's just say that it's a 99-cent item. All right, so there's the situation before, but it's reversed. Is it possible that that code, that very code for that unique item, would actually not be 99 cents the next time somebody came through? No, unless they change the price. So there's no way that I can make an open beak. There's no way, because it's not going to have, one code is not going to have two prices, one for one person that scans it and another for another person that scans it right at the same time. So here's what we can conclude from that. B is a function. Again, my goal is to try to make an open beak on a bird. And if I can't, then it's a function. B is a function of A. Now, that just means is a result of. Okay, so there it is. That's how to use the phrase is a function of. So this one is not. Hope this helped. Thanks for watching.